everyone for letting me share a little bit of my research. So this is a project we did in 2021, and we looked at supplementing metabolizable energy during late pregnancy and the effects on cow and calf performance and colostrum yield and quality. So during late pregnancy, the cow has a lot of nutritional demands. Her fetal growth is exponential, and after month 7, so in those final 2 months of pregnancy, the calf can gain up to 60% of its final birth weight. And then at the same time, as it gets closer to calving, around 5 weeks before calving, colostrum production starts. And that also involves the preparation of the mammary gland for lactation after calving. So both fetal growth and colostrum production require large amounts of energy and glucose from the cow. And at the same time as this cow is under really heavy energy demands, she has changes to her gastrointestinal tract that limit her ability to utilize her diet. So the first one is that the cow will have reduced feed intake, and this is due to a combination of abdominal crowding and hormonal changes that occur during pregnancy. The next change is increased passage rate, and this is associated to reduced feed intake. So the feed will move faster through the gastrointestinal tract, and it'll have less time exposed to enzymes, and therefore digestibility might be reduced in some components of the feed, including starch. So all of these together, the reduced feed intake, the increased passage rate, and the reduced digestibility mean that a cow that's fed a diet that's balanced perfectly, it should theoretically meet all of her requirements, may not be able to eat enough of the diet or use it enough to actually meet those requirements. And that, in combination with those high energy demands, means that energy deficits are really likely in those cows during late pregnancy. So what does this mean for you? When a cow experiences an energy deficit, she's going to mobilize her body reserves. So you're going to see cows losing body condition. And then there's also an increased risk of calf mortality. So this can be due to a few different reasons. The cow might not have enough milk after calving, which we didn't look at in this study, but she may also have reduced colostrum yield or unintended effects on calf performance due to fetal programming effects. So fetal programming occurs when there's a challenge to the dam during pregnancy, and it changes how the genes are expressed in the calf. And this can affect calf performance from birth and in early life, all the way out to weaning, in the feedlot, in the abattoir, or when they join your herd as a replacement heifer. So with all of these effects in mind, we wanted to look at if supplementing energy beyond the cow's requirements during late pregnancy could correct those energy deficits I mentioned, and if it would support colostrum production. So this is why colostrum matters. Colostrum's the first milk that's produced by the cow after she has her calf, and it's rich in a bunch of components like fat, protein, IgG, which is an antibody, and a bunch of growth factors and hormones. So fat and energy are really important for thermoregulation. A lot of the calves here in Ontario are born in the spring and need that little bit extra to keep them going when it's cold. So that's what the fat and energy are good for. There's protein, also energy, growth factors, and hormones that keep that calf growing in the first week or two of life. And then the other component we wanted to look at is IgG, which I mentioned is an antibody. So calves are born without their own immune cells and rely entirely on the colostrum to pass that transfer of immunity from the dam to the calf. And without that, poor colostrum quality or insufficient quantities can lead to increased morbidity or mortality in calves. So to look at the effects of over-supplementing energy during late pregnancy, we enrolled 152 pregnant Angus Simmental beef cows, and we housed them at the Ontario Beef Research Centre at University of Guelph. Around 53 days prior to calving, we randomly assigned these cows to one of 3 treatments. The first treatment is a low ME diet. ME is metabolizable energy. So our low ME diet provided 80% of metabolizable energy requirements, and we fed this at 1.35% of body weight. We had a control ME diet, which met ME requirements, and we fed this at 1.4% of body weight. And we had a high ME diet, which provided 120% of ME requirements, and we fed this at 1.45% of body weight. And we use these feeding rates just to ensure that cows weren't over-consuming energy relative to their treatment. Affect these changes in energy across treatments, we included starch sources in the control ME and high ME diets. So the control ME diet had high moisture corn, and then the high ME diet had high moisture corn and whole corn. And like I mentioned before, there's really high glucose demands on those cows during late pregnancy. And when cows are digesting starch sources in the rumen, it's not absorbed in a form that readily goes to glucose. So by adding whole corn to our high metabolizable energy diet, our goal was to have that whole corn pass the rumen and be digested in a form that more readily provides glucose to those fetal growth and colostrum demands. We collected samples for cow and calf performance. The cows we started sampling 56 days prior to calving, and we continued with the cows and calves to 56 days after calving. And then again at weaning, we took some performance measures and blood samples. And then at the time of calving, we collected yield on a subset of cows, so 16 per treatment. And we collected it using this little portable milking machine you can see in the photo. And then on every single cow that calved, we hand stripped out a sample and used that to assess composition and IgG content. So now we can go through some of the stuff that we found in this study. So we did find that colostrum yield was greater in those cows that were supplemented leading up to calving compared to the cows that were fed under their requirements. And then when we look at composition, we do see that the low ME cows did have a greater proportion of crude fat, crude protein, IgG, and gross energy. So this means that the high ME cows, the ones that were supplemented, had a less nutrient-dense colostrum, although they produced more. But when we look at total component yield, we see that those high ME cows had greater total crude fat yield, greater total crude protein yield, greater total IgG, and greater total gross energy output. So if you work under the assumption that the calf can consume all of the colostrum that the dam produces, there is more nutrients available to those calves from the high ME diet. In addition to the changes in colostrum yield and composition that we saw, we also saw that the cows that were supplemented leading up to calving maintained their body condition better than the cows that were fed under their requirements. So we used conceptus corrected body weight here, and you can see the changes throughout the prepartum period or before calving. So we used conceptus corrected body weight because it accounts for fetal growth. So what you see here is changes to the dam's true body mass throughout that time period before calving. So the high ME cows gained mass during that prepartum period, whereas the low ME cows lost mass. We also saw that the low ME cows lost rib and rump fat depth at a greater rate than the high ME cows during that period before calving. And this was reflected in some metabolic indicators of energy balance that we looked at. So serum non-esterified fatty acids, or serum NEFA, is an indicator of fat mobilization. And you can see that the cows that were fed under their requirements, those low ME cows, had greater serum NEFA, and that indicates that they were mobilizing fat throughout their body to meet those energy requirements during the prepartum period. And then, as I mentioned before, glucose demands are high, and the goal of our high ME diet was to more directly address those glucose demands. So in the figure on the right, you can see that serum glucose was greater in those high ME cows that were supplemented before calving than in the low ME cows that were fed under their requirements. So although we saw differences in colostrum yield and composition and cow performance, we didn't see many carryover effects into the postpartum period in regards to calf performance or cow performance. So dam metabolizable energy intake before calving did not affect birth weights, calf body weights to 60 days of age, or weaning weights. But we did see an interaction between dam treatment and dam parity for average daily gain in the first 7 days of life. So you can see that calves from multi-parous cows fed the low ME diet had greater 7-day average daily gain than the calves from the multi-parous cows fed the high ME diet, or calves from primiparous cows fed the low ME diet. So as we saw in the colostrum tables, there was greater yield with those high ME cows, but it was less energy dense or less nutrient dense. So these multi-parous cows that are already producing a lot of colostrum, this may be because if they're producing a lot of colostrum and it's not as energy dense, those calves can't consume enough to get those nutrients compared to the ones on the low ME and for those multi-parous cows. That's a potential explanation for this interesting result. So overall from this study, we learned that oversupplying metabolizable energy during the final months of pregnancy can increase colostrum yield. It can conserve cow condition prior to calving so that you don't have to worry about putting it back on after calving. And it didn't increase the risk of high birth weights. So there isn't a risk associated with it in this study for making calving harder. This oversupply of energy can be achieved through grain supplementation during the final months before calving. And it may be particularly beneficial to herds that are feeding low quality or high fiber forages. So this research wouldn't have been possible without our funding agencies. Sample collection definitely wouldn't have been possible without the staff of the Ontario Beef Research Centre and the help of the other members of Dr. Steele's lab at University of Guelph. So thank you for listening.